Okay, dear student, let's see what is there in this question. Monochromatic electromagnetic radiation is incident on a metal surface. The kinetic energy of the electrons released from the metal. So it's talking about the energy with which the electrons are moving now once they're coming out of the metal surface is constant, because the photons have constant energy. First of all, the kinetic energy of the electron is not constant. Every other electron is having a different kinetic energy. Many people have this doubt. People feel like that all the electrons are moving with the same kinetic energy, but that is not the case. I tell you, and I can prove it. See, this is the graph for the stopping potential, and this is the voltage, and this is the frequency. So there is a certain frequency at which, at this point, certain frequency at this point, the the stopping potential becomes zero. Sorry, I think I've done it wrong. Yeah, this is potential, and this is the photocurrent. Sorry. Now accordingly, you can see that when the voltage which is used is negative, and but it is not as powerful as the stopping potential, some electrons are returned back to the base. They are not able to reach the other side, which are like these electrons are getting out of the out of the metal, but they are still not adding into the electric current. Why? Because they are now returned back to the other plate. So as the voltage keeps on increasing, more number of electrons are going back. Only at the stopping potential, the electron which is having the maximum kinetic energy is now stopped from going to the other plate. So it means that every electron is having a different kinetic energy. It's very clear from this graph. So it is not constant, it is not equal for all the electrons, it is different. Now why it is different? So first of all, it varies. But why? It varies because the electrons are not equally bound to the metal lattice. Absolutely correct. Because the work function of the metal is different for different electron. Absolutely wrong. Why? Because work function is the function of the material. Like for zinc, the work function is so and so. It's not like for this electron it will be this, for that electron it will be this. It's not like that. So work function for a metal will is a constant value, and it is defined as minimum energy required by the electron to jump out of the metal lattice. It means that you're talking about the electron which is most loosely attached inside the material. All other electrons, they will be bound in the lattice, but they would be needing more energy to get out. That is why they would be having lesser kinetic energy when they come out, because the photon was having the constant energy every time. So more energy is wasted in coming out of the lattice, lesser is the kinetic energy with which electron is moving now. That is why C will absolutely be the correct answer for this question. So this is how we do this. Okay, dear students, I believe everything is good, and you might have understood the concept behind this. This is Professor Varun. Thanks for watching. All the best.